Companies built bigger batteries, introduced faster charging, and expanded charging networks. But in India, this concern has still not disappeared completely. Whether it is Tesla or BYD, both have tried to reduce this problem. But a single solution that works everywhere, on every Indian road, has still not been found. But now an Indian company has taken a step that has caught the attention of the entire auto industry. The most surprising part is that this time it wasn't about buying better battery cells from China or Korea. Instead, this company decided to build its own battery cell from scratch, inside India, and put it on the road. It is Ola Electric, the same company most people still think of as a cab-hailing app. Now the question is, what is a ride-hailing company doing designing battery cells that rival global giants? Has India really built something that could reduce the country's dependence on foreign battery technology? We will find out why this happened, how the technology works, and whether it can really become a new challenge for big companies like Tesla and BYD. Before we go further, if you haven't subscribed to this channel yet, now is a good time. To understand why this story matters, we first need to understand India's specific EV problem, because it isn't quite the same problem the rest of the world talks about. Everywhere in the world, people worry about charging stations and range anxiety. India has that worry too. But India has a second, bigger problem sitting underneath it. Almost every battery cell going into Indian EVs was being imported, mostly from China. That means when cell prices went up, or when supply chains got disrupted, Indian EV makers had very little control over their own costs or their own timelines. So while the rest of the world focused on bigger batteries and faster chargers, India had to ask a more basic question first. Can we make the batteries ourselves, or will we always be dependent on someone else's factory on the other side of the world? Ola Electric did not start as a battery company or even a vehicle company. It began as Ola Cabs, a ride-hailing app, founded in 2010 by Bhavish Agarwal. For years, it was known simply as India's answer to Uber. Then, around 2017, the company pivoted hard into electric vehicles, starting with electric two-wheelers. This was an unusual jump, a taxi app deciding to become a scooter manufacturer. But Agarwal's argument was that India's next transportation revolution wouldn't be about who owns the app. It would be about who owns the electric drivetrain and the battery underneath it. By the early 2020s, Ola Electric had become one of India's largest electric two-wheeler sellers, competing with brands like Ather and Bajaj. But like nearly every EV maker in India at that point, it was buying its battery cells from outside the country. Agarwal made no secret that he saw this as a long-term weakness, not a permanent arrangement. That is where the real story begins. Ola Electric set up a subsidiary called Ola Cell Technologies and built a gigafactory, with the specific goal of designing and manufacturing its own battery cells in India, rather than simply assembling imported ones into packs. The first major result of this effort was the 4680 Bharat cell, an indigenously developed lithium-ion cell using NMC chemistry, unveiled at the company's Sankalp event. Alongside it, Ola also introduced a ferrite motor that does not use rare earth magnets at all, directly targeting one of the most sensitive dependency points in EV manufacturing, rare earth materials, which are overwhelmingly controlled by China. By early 2026, Ola Electric had begun mass deliveries of scooters powered entirely by its own 4680 Bharat cell battery packs, making it the first Indian EV company to own both the cell and the pack manufacturing process in-house, rather than depending on outside suppliers for either. Then, in June 2026, Ola Cell Technologies reached another milestone. It received Bureau of Indian Standards, or BIS, certification for a new cell, the LFP 46100, making it the first Indian company to receive that certification for an indigenously developed cell in this format. Now, how is this different from what most EV batteries already do? To understand that, we need to look at two things: the chemistry and the format. Ola's first cell, the 4680 Bharat cell, uses NMC chemistry, nickel manganese cobalt, which is generally chosen for higher energy density, meaning more range from a similar-sized battery. The newer LFP 4610 Chevry cell uses lithium iron phosphate instead, a chemistry that trades a bit of energy density for better safety, longer cycle life, and lower cost, since it avoids expensive and geopolitically sensitive materials like cobalt and nickel. The LFP 4610-100 cell offers an energy density of over 170 watt-hours per kilogram, is built to handle a wide range of operating temperatures, which matters a great deal in Indian summers, and is designed with a development path toward more than 4,000 charge-discharge cycles, meaning the battery should last through many more years of daily use before it degrades significantly. The clever part of Ola's strategy is that both the NMC 4680 cell and the new LFP 4610-100 cell are built on a shared 46 series cell architecture. In plain terms, that means the company can manufacture two different battery chemistries on largely the same production line, and then decide which chemistry suits which vehicle. High-performance cells for premium scooters and motorcycles, lower cost and longer-lasting cells for mass-market scooters or stationary energy storage. This is very similar in spirit to how BYD manufactures its own blade batteries at scale, or how Tesla designed its own 4680 cell format years ago, except this time, it's happening inside India, aimed first at solving India's own cost and import problems. The battery cell isn't the only piece of this story. Ola also introduced a ferrite motor that removes rare earth magnets from the drivetrain entirely. Rare earth elements are a major choke point in EV manufacturing worldwide, since a small number of countries, China chief among them, dominate their supply and processing. By developing a motor that performs without depending on rare earth magnets, Ola is attempting to remove a second major point of foreign dependency, not just the battery cell. Combined with the indigenous battery, the company is aiming for what it calls full supply chain independence for its vehicles, meaning the two most expensive and strategically sensitive components of an EV are no longer sourced from outside India. Ola Electric is not working alone in this space, and it's important to understand that this is part of a much larger shift happening across India. Tata Motors, through its battery arm Agratas, has signed major deals to build its own battery manufacturing plants in India. Reliance is building a battery gigafactory of its own, expected to begin operations around 2026. Companies like Amara Raja and Exide, long known for lead-acid batteries, are now expanding into lithium-ion cell production as well. On top of that, Indian researchers and companies are actively working on sodium-ion battery technology as a longer-term alternative to lithium. Sodium is far more abundant than lithium, can be extracted from the Earth's crust and even seawater, and does not carry the same supply chain risk. Sodium-ion cells are generally cheaper to produce and safer, since they can be discharged fully without the fire risk associated with over-discharged lithium cells, though commercial-scale adoption in vehicles is still expected to take a few more years to mature. India's public charging network is also expanding quickly alongside all of this. By late 2025, India had crossed 12,000 public charging stations, with plans to pass 20,000 by 2026, backed by companies like Tata Power, BP Pulse, and Indian Oil, adding fast-charging corridors along highways. So the indigenous battery push isn't happening instead of infrastructure growth, it's happening alongside it. Now the real question, if Ola's approach proves successful, how much does it actually affect global giants like Tesla and BYD? Tesla's strength has always been its ecosystem, large batteries, its own supercharger network, and a software-driven driving experience. But Tesla's model depends heavily on markets where charging infrastructure is already mature, something India is still building toward, market by market, city by city. BYD's strength is different. It manufactures nearly everything itself, including its own blade battery cells, at massive scale, which lets it offer competitive pricing in many markets around the world, including parts of Asia. Ola Electric's strategy sits somewhere else entirely. It isn't trying to outscale BYD or out-software Tesla. Its goal is narrower and more specific to India's problem. Reduce reliance on imported battery cells and rare earth motors, bring costs down for the Indian buyer, and build a domestic battery ecosystem that doesn't collapse if a foreign supply chain gets disrupted. In other words, this isn't really a head-to-head fight with Tesla or BYD on their own terms. It's India trying to solve a uniquely Indian version of the same underlying problem, energy independence and affordability, using its own manufacturing base. Looking ahead, Ola Electric has already signaled where it wants to take this. Beyond scooters, the company has entered India's battery energy storage market with a residential product line called Ola Shakti, built on the same Bharat cell technology and gigafactory infrastructure, aimed at the much larger stationary energy storage demand expected in the coming years. The company has also outlined ambitions around sodium-ion and next-generation chemistries as part of its longer-term roadmap, alongside government-backed production-linked incentive schemes designed to pull more of the battery supply chain, from raw materials to finished cells, inside India's borders. None of this means India's battery independence is complete. Cell manufacturing at this scale is difficult, capital-intensive, and takes years to mature reliably. But what's clear is that India is no longer just assembling other countries' battery technology. It's starting to design its own, on its own terms, for its own roads. If you found today's video useful and want more simple, reliable breakdowns of EVs, batteries, and the auto industry, don't forget to like and subscribe.